This should be interesting and should be quick, and I expect to be done in about 20 minutes. And if at any point you feel like you've had enough of this and you want to slip away, there'll be no offense taken. The size of the text, okay. So before this evening started, Alexei interviewed me on camera, and so you should go and watch that rather than me talking about this. But I will say that Carl Quinn and Dick Wall of the Java Posse turned me on to Scala about 10 years ago. Okay, so this talk is about 3D graphics with processing. And processing is, in their words, I'll let you read that there, kind of combining programming with visual arts. And you can download it from processing.org, and it works with Java and Python, and there's a JavaScript spin-off called P5.js. But if you install the product and then you go and get the jars and attach those jars to your Scala project in your IntelliJ IDEA or whatever you like, then you can do what I'll be showing you. I have some resources. Another reason I'm going to keep it short tonight is if you're really interested in this, I have a whole bunch of YouTube videos where I walk through Scala code that does this 2D and 3D graphics and animation and things. So, and also the code is on GitHub, so if you're really into it, go get it. Otherwise, tonight can be just an introduction and expose you to it a little bit. I have a bunch of quick demos, and then I want to do a group coding exercise. I thought we would try to make a 3D red spiral inspired by the Scala logo and then have it rotate at the end. So, you know, and I printed out my little cheat sheet for that, and then I forgot to bring it, so it would truly be recreating it live. I did do it. I'm no dummy. I did it beforehand. Okay, so what do I have for you here? Let's start with a very simple program that I call draw. And let's see, what should I do? Should I put this along the left, put this on the right? Now we're going to need that more full screen. Okay, so here's draw. Very small program. I'll run it and then we can briefly look at the code. And it should run full screen. Okay. And please ignore this strange beginning of it, but this just takes the mouse's current position and the mouse's previous position and draws a line between the two, while all the while cycling through the hues. This uses, I don't know if you know color models, you know about RGB probably. Fewer people know about hue, saturation, and brightness. So the hues just go around the colors of the rainbow. So what do I want to show you here? Here's the basic, obviously this is Scala. This class extends papplet, which comes from the processing core package. And this bit of code here turns it into full screen mode, and this, oh, that's interesting, because this is not really a 3D program, but by mistake I made it operate in the 3D mode. Here's where we turn on the hue, saturation, brightness mode, and then you notice the lines at a certain thickness, they're 4 pixels thick. And then stroke here, this sets the hue, saturation, and brightness. And the hue is a function of the frame count, modulo 360, which is all the way around the hues, so just cycles through the hues. And 256, 256, those are the maximum default values for the saturation and the brightness, just like you're probably used to with RGB. And then as I mentioned, it draws a line from the previous mouse position to the current mouse position. And then we need this companion object to get processing to launch our program, which is up here. All right, so that's one. Here's another one that shows a little bit more about the HSB. So that's called HSB blocks. And with this one, I even put a little helpful message up there. So if I press space, it stops cycling through the hues. And you can see if I go all the way left, it gets less and less bright. So the x-axis is the brightness, and the y-axis is the saturation. So just kind of a look at the HSB color model. And this program is a little bit longer, and I think I'm not going to go through this one. Okay. So next is brute force sphere. So it randomly generates points in a space, a cube volume, and then it uses the Pythagorean theorem to find out which points fall on the surface of the sphere. So I call it brute force for those obvious reasons. So I started out with a circle, and then I went to 3D. So here's brute force sphere. I hope it shows up nice here, if you can see it at all. Is anybody seeing any stars starting to form? Not really stars, these things. So you see the ones, the coloring works. I don't remember if this is green and then blue, or if it's green kind of making a gradient into blue. I'm not sure if you can tell. But it generates these points. It's up to 790,000 points that it's generated. And it calculates that about 71,000 of those are on the surface, where surface is defined as some thickness. And the frames per second is going to slow. It's down to 17. And it's erasing and regenerating this picture for 14 times a second now.
So you're just randomly picking a point and then drawing it if it's in that shell?
I think they're all drawn, but the coloring, actually, no, we didn't see anything outside the sphere, did we? So if it's inside the sphere, it's drawn, and then the color of it is whether it's close to the surface of the sphere. And somewhere in here, there's add batch of points, points to add each frame. So it adds for every frame, and I think 30 frames per second is what we're looking for. For every frame, it adds 1,000 more points. So that's happening pretty fast. It's getting pretty big, pretty thick, dense, I guess is the word. Dice histogram. I like this for my students who are learning about probability. I teach kids in grades 3 through 12. So dice histogram, and I think many of you will see immediately what this is. Recognize it? Why do you roll a lot of 7s? Because there are, is it 6 ways to make a 7? How many subdivisions are in here? Now, who can figure out what the red and the green means? And why sometimes it doesn't fill the lines? Why sometimes it goes out above the lines? This is, anybody can tell yet? So we have a simulation, so we're using a pseudo-random number generator. We also have what's expected by probability. So the green is where you're getting more than would be expected by probability. So I tell kids, write a little program that simulates throwing a 6-sided die, and they do that. Then I say, write a program that simulates producing the sum of throwing 2 6-sided dice. And then, as you can imagine, they generate random numbers between 2 to 12 with a uniform distribution across that, which is obviously not this. So then I bring this out, and then it becomes clear. Okay, particles towards center. That's here.
I don't know if you have time, but can you show us the code that actually does the graphics?
Let's come back if there's time. I want to just go through these quickly. I just want to see if this is the one this I originally wrote for P5.js in JavaScript, and I just converted it to Scala today for this. Okay, so this, again, you'll recognize I often cycle through those hues. The way this works is a function of the mouse position. So there's the density of the particles, and then there's the speed at which they travel towards the center. I don't know whether you've noticed, but every particle here is moving directly toward the center. There's no, anything else you see is an optical illusion. So let me just move around a little bit here. So what happens up in this corner? Okay, the density increased. The speed at which they move to the center increases. What about down here? And I'm pushing the space bar to clear the screen. So now, to me, it looks more like they're not directly moving toward the center, but they're kind of, swirling around or something. So that's kind of fun. And image push. This is nice. How many of you are colorblind and would wish to share it with the group here? Anybody colorblind? I have a little program that would help the colorblind. So what did I call it here? Image push. Image push. Okay. If you were at the meeting a couple of months ago, you saw a version of this running with a different file. So, you ever seen this? Okay, so what if we could kind of push the green things closer to us in 3D and then rotate around? So watch this. There, the green stuff. So I took the image apart, pixel by pixel, and then looked at pulled out the RG and B separately, and then looked at those RG and Bs to choose the Z value for positioning this in space. Okay, we're doing pretty well on time. Cube of cubes. This one is surprisingly easy to do. I mean, you see a gradient in there, some color stuff. You see rotation. You notice that the individual cubes that make up the giant cube are themselves rotating. The whole business is rotating on 3 axes, I think. But this is one of the shortest programs here. You see, look at this. That's just 35 lines. And the drawing all happens in here. So you recognize this construct from Scala, something to something by something, that gives you a range. So here's the range. And then a 4 comprehension with 3 generators, 1 for each of X and Y and Z. And then translate, rotate, set the fill color, and draw a box. Well, actually, there's some other, okay, there's some other code here. Sorry. All right, so I forgot about this part. A chessboard. And I'm a little embarrassed to admit, it took me a while to figure out just this part of it. How do you know if it's a black or a white square? And I was doing this with a student, so it was really embarrassing because you think this is a sort of thing you can easily find a way to choose sort of white or sort of black, depending on something with the X and the Y. Anyway, that works. Anybody have a better refinement of that? So that produces this. So you can move it. Notice you can rotate it a little bit with the mouse X and a lot with the mouse Y. And so here's the rotation on X that uses the mouse Y. And the range of that is from pi over 2, which is 1/4 of the way, right? And then, is that right? Pi over 2. 2 pi gets you all the way around. Pi gets you halfway around. Pi over 2 gets you 1/4 of the way around. This works with radians. The P5JS, the JavaScript reimagining of processing, has a degrees mode that's sometimes more convenient. Okay, so we're working our way up towards our little coding project here. Yeah, so here we are. So I want to make a red spiral inspired by the Scala logo. So let's see. EPFL stairs. There's some pictures of the stairs. And there's also the Scala logo. So I want to do just some sort of spiral thing. And maybe we can make it out of rectangular solids that are the steps, make them red, and then have them kind of wind their way around a circle and then go up as we increase. Okay, now I mentioned that I printed out my little notes. And I wasn't going to commit the code to GitHub because I didn't want to have a spoiler for anybody who followed my links. But let's see if we can do it. And we'll start off simply. If we run out of time, that's fine. I'll run like the old cooking shows, I'll bring the thing out of the oven at the end so you get to see it. But I will stop. How about if I stop at 8:55? So we'll have 5 minutes and see what we can do. Okay, so I want to make a new project, but I want to start. I don't want to have to write all this stuff here, so let me start maybe with this template, and then I'll make a new thing here. Let's just call it stairs for the moment. And I'm going to throw it away when we're done. And I'll just do, replace that with stairs everywhere. Okay, so this should run. And that's what you get if you don't set the size or anything. But I want some, I want to go into 3D mode and I want it to be full screen. So let me grab that from one of the other programs. Let's see, this one. Here we go. Okay, we'll put this here. Now it should be full screen in 3D, although you won't know about the 3D yet. Okay, there we're full screen. And we need to draw a stair. Let's start with a single step. Okay, so to do that, we need to use box. And if I say box, say 50, here's what we'll get. There's a box up in the top left corner. So what I usually do is I'll do a transformation. So there's a bunch of these. I'll do a translation transformation. There's a bunch of transformations you can do. So I'll translate over to the center. So there's a variable called width. And then I'm going to start drawing, and y is inverted, so y increases as you go down. So I'm going to just say, give myself some margin here. And then I'm not changing anything on z. So this should put the first step centered horizontally up toward this top. Okay, so maybe a little more margin. And now we need to make it look more like a step. So I'm going to cheat here and see what I came up with. 50, 10, and 30. So this makes more than cubes. It makes I think these are called rectangular prisms, right? Okay, let's make it red. So we want to do a fill. Oh, but first I want to turn on the HSB color mode. So I need I'm going to override the setup method. And in here, I'm going to use color mode, HSB, and I'll need to import that. I don't know why IntelliJ isn't helping me with the import for that. But that's in pconstants.hsb. Okay, now we're in HSB color mode, and then I can do a fill. And red, if you look at HSB, I don't know if you ever see those color HSB triangle things where you start with the hue. So the red is 0. And then I'm also going to add, 1 minute left, I'm going to add, this is a maximum. So the hue is 0, saturation is maximum, brightness is maximum. So this should be red now. Okay, so there's one step. Now we need to do really far more than we have time for, so I'm going to jump to the oven where I have the finished work, I think. And so that is here, spiral stairs. So how long is it? It is 44 lines of code. What was left out? Well, I noticed that the EPFL staircase has 4 revolutions, so that's why the 4. I didn't bother to say, you know, how big is the stair and how much turn do you have each time. So here's the final result, and then we'll stop with about 5 seconds to spare. There it is now. When I press spacebar, here's the fun part. A nice little rotation. Okay, so that's Scala and processing. See you guys next time.
Yeah.
Thank you.